Hi guys, welcome to my talk ES7, the evolution of JavaScript. First I'll talk a little bit about myself. I'm Netflix's cross-team technical lead. I work across all the various UIs. I'm the architect of Netflix's UI data platform, and most importantly for this presentation, I'm on the TC39, which is the JavaScript Standards Committee. Now, ES6, the forthcoming version of JavaScript, will be standardized in June 2015. So you'd be forgiven for asking the question, isn't it a little too early to talk about ES7? Well, as a matter of fact, the answer is no. In fact, you might be surprised to learn that features are actually rolling in to browsers right now from ES7. So I think the important thing for most JavaScript developers out there to understand is that ES7 is not going to be like ES6. ES6 was a major release that came a long time after ES5, whereas going forward, the committee is moving more towards like a train model, like we use for software, where every year we're going to be releasing rapidly, and those features that just aren't ready won't make it into that release. So ES7 is going to come not too long after ES6. So with ES7, what we're doing is we're really building on top of ES6. And this co-evolution, this co-design of ES7 and 6 means that we can really start to think forward and sort of intelligently plan what's going to go in ES6 and how they're going to play together. And that's a lot of what I'm going to be talking today in my presentation, about how ES7 features build on top of ES6 to solve the types of problems that web developers are facing. So the first feature I'm going to talk to you guys about is arrow functions. And this is one of my favorite features from ES6 because it really allows you to write functions in a much more terse way. Now, most people are familiar with how you write a function in ES5. Now, starting in ES6, you'll be able to get rid of a lot of this boilerplate and actually shrink this down to a simple arrow. So I'm going to be using this particular usage of the arrow function throughout the slides going forward. Now, I know there's a lot of folks out there who use an MVC framework. Now, today I want to focus on one particular part of the MVC triangle, and that's the model and view. Now, a lot of people out there use frameworks like Ember or Backbone, and all of these different frameworks have different approaches to doing model-view synchronization. And none of them is sort of really one out. They all have their, their benefits and drawbacks. Now, Ember, for example, forces you to go through special setters and then does dirty checking. Angular waits until after every event and then diffs the model from what it was before, and Backbone.js sort of leaves it open and you can sort of figure it out yourself. Now, all of these approaches, as I mentioned, have positives and negatives. So the question is, why can't JavaScript support change notification natively? I mean, if all these frameworks are doing this, why can't we help out and basically improve the performance of this approach and come up with one approach that works for everyone? Well, that's the first JavaScript 7 feature I'm going to talk to you guys about, which is Object Observe. Now, I think a few folks out there have heard of Object Observe. It's probably the most popular, it's probably the most discussed, the most publicly discussed feature of JavaScript 7 up to this point. Now, let's take a look at how Object Observe works. Let's say I want to observe a person object, for example. So as you can see in this slide, I'm going to create a changes handler. Notice that that arrow means function. And I'm going to hook it up to the person using this Object Observe method. Now, what that means is if I make changes to this person object, I'm going to be able to get a notification. In fact, what I get in my callback is an array of notification objects, of change objects, excuse me. So if we come along and we decide to change Dana Miller's name to Dana T. Miller and include the middle name, be a little verbose, we're going to get an array of changes. And the first change says what type of change it is. It's the update. It says what property has been updated, and it also gives us the old value. Now, let's say that Dana starts working at a company, Tommy's Boxstar. Now, because we've added a property, this time our change notification is going to say that we've got a new property, and the name is an employer. Now, what if I change property descriptor values, like enumerability and so on and so forth? Let's say, for example, that I made this particular property immutable, Dana T. Miller. Well, I'm actually going to get a notification about that, and we're going to say that this particular property is reconfigured. Now, finally, let's say Dana doesn't work at the Boxstar anymore. He decided to leave. It's a pretty boring place to work. And what we get is a notification that a property has been deleted. We get the name of the property and the old value. Now, if you can unobserve an object, you should be able to unobserve that object. So here I am, same thing as before. It's very similar to, say, add event listener, remove event listener, for those of you familiar with DOM events, right? We just pass in the person object and the changes handler again, and now we won't get any more notifications. Now, it's really important to understand how this works from an event loop queue perspective. Now, if we were to do the most naive thing, which is batch up a bunch of changes within a single tick to an object, and then schedule it using something like setTimeout, we might not get the response we want, or the behavior we want, rather. So here's a list of tasks on the event loop. We're running the first task. Let's say an event happens, and it causes us to change two properties on the person object. Now, we generate a notification, and if we were to use setTimeout, for example, that would go to the back of the event queue. And now, if you notice, what's going to happen is we're going to process the browser render before we've even had an opportunity to handle this notification and maybe make changes to the DOM. Now, that means we're going to render the browser, or rather render the screen, reflow, and then reflow again after we make these changes. So it's not really optimal. So in ES7, we're taking advantage of something that we've added in ES6 to avoid the notification storm. Sometimes this is called the notification storm problem. And that's this concept of microtasks. Now, ES6 is a really important release because it's the first time we've actually said that JavaScript has some control over the event loop. Up until now, it was really the browser or Node that really controlled the event loop and just sort of called into JavaScript, and it didn't have any control over the event loop. But with 6, in order to make things like promises faster and eventually object observe faster, 6 has this new concept of microtask, which sort of interacts with the event loop. So let's see what happens with microtasks and object observe in ES7. So how does that change? Well, we have the same thing as before, tasks on the event loop. Let's say a mouse move happens. We click an event handler or something. We make a couple of changes to the person. We batch up all those changes, and we schedule an observe handler. But this time, instead of using setTimeout, we use a microtask, and that causes the observe handler to actually jump to the bottom of the stack. And this observe handler is going to get executed only when the stack of the current task on the event loop bottoms out. And so notice we execute the observe handler and get a chance to update our DOM objects before the browser renders. And that's how we efficiently update the DOM and prevent unnecessary reflows. So you can see here, you can maybe make a change to a model and then propagate changes to another model before finally updating the DOM and then getting a single render pass. So you can try Object Observe right now by opening up Chrome and enabling experimental JavaScript. So Object Observe is actually in the draft stage of the ES stages, and I'll talk a little about those. So it's very early, obviously, and in order to talk responsibly about ES7 features, we have to understand the feature maturity stages. Now, feature maturity stages are a way for the committee to let developers know exactly how far along the standardization process each of these features are. So as you can see, async await is in the draft stage. And what that really means is the committee expects the feature to be developed and included in the standard. And so that means it's safe, I think, to start playing with this feature and start giving the committee feedback. Now, a lot of JavaScript developers out there have to deal with async programming. And it's probably a worthwhile question to ask, how can ES7 make async programming easier? Well, I think we're all familiar with the concept of blocking. And blocking is easy. Here's an example of a function where we get the stock price for a given name of a company. Now, the first thing we do is retrieve the symbol for that name, and then finally we pass that symbol to a getStockPrice method, and then get the price out and finally return that. Now, this is just a series of, functions that we call one after the other. Now, in this particular example, each of these functions block. And if we were to, say, use a synchronous XHR request to make this call, we would be blocking and we'd be preventing, say, the user interface from responding to anything else the user does. And if we were on a web server, we'd be preventing processing any other requests. So in practice, especially when we're working with I/O, in JavaScript, because it's a single-threaded language, we don't want to block. We actually want to wait. Now, if we decide to wait instead of block, that means our user interface will stay responsive and our web server will serve many more requests. The only problem is, as soon as we decide to wait instead of block, we run into a little problem called the pyramid of doom. I'm sure there's developers out there who know what I mean. The pyramid of doom is the structure of code that we end up with if we want to avoid blocking, and we'll find that it mangles our code so much. Now, see, notice in this area, we have this pyramid structure where callbacks are sort of within callbacks. And worse than that, we have to worry about forwarding errors ourselves, using this explicit sort of error forwarding mechanism, what try-catch does for us normally. So in JavaScript 6, we introduced this concept of promises. Now, promises are an object that represents a value that we'll eventually get asynchronously. So let's take a look at this. Now, you can get the value out of a promise by handing it two callbacks. The first callback receives the value if it successfully is retrieved. The next callback receives the error if it is unsuccessfully retrieved. And so you see we have two possibilities. A promise could evaluate to a value or it could evaluate to an error. Now, as we can see using promises, we can actually write code that's a lot cleaner. We can kind of get rid of that pyramid of doom. We have a little bit of nesting, but it's not as much. And we can also handle errors, or rather promises handle errors for us. So it'll actually propagate errors for us, so we don't need to keep pushing them back up. Now, this code's actually pretty good. In fact, it's pretty readable, especially with arrow functions. But we could probably do better. I mean, since waiting is such a common thing in JavaScript, why does the code have to look so different than blocking? And that's something we're really concerned about in JavaScript 7. It's something we're very focused on, how we can make waiting feel just as natural as blocking. So, as a matter of fact, in JavaScript 6, you can take advantage of these two features, promises, and a new feature I'm going to be talking about in a moment called generator functions, to write code that waits and looks very similar to code that blocks. So you should be able to write code that looks like this, for example. So notice here the function has an asterisk at the end of it, and we're using this special yield keyword, which I'll talk about in a moment. So in order to understand how this works, I need to explain what type of function this is, which is a generator function. So a generator function, I'll explain a little bit about it. A generator function, I think the way for most developers to think about it is it's just a function that can return multiple values. Now, here's an example of a generator function, a pretty trivial one, that returns multiple values called getNumbers. Once again, we see that asterisk on the end of the function and the use of yield instead of return. Now, how exactly could a function return multiple values? How can we sort of consume those values progressively? Well, the way it's done is by iteration. Notice here I'm going to call this getNumbers function, and I'm getting out of this Iterator object. Now, an Iterator object is a data source that you can pull values out of one at a time. So let's see what that looks like. I call next on the iterator, and I get out this little tuple, that has the value that I just retrieved, and also this Boolean telling me whether I'm done or not. Now, so notice that we're not done. That says false. So I, as the consumer of this data, call next again, retrieve another value. It says we're not done yet. I call next one last time. Finally, I get a Boolean telling me I'm done. So the way iteration works is it's really a pattern that allows a consumer to pull values out of a producer one item at a time. So let's take a look at what that kind of looks like. First, the consumer requests an iterator from the producer. In the previous example, that was just our function. We just called the function and got out an iterator. And then the consumer, at its leisure, calls next, pulls the next value out of the producer. And we just keep doing that until we get an explicit signal that we're done. So in ES6, all the collections, array as well as the new set and map collections, are iterable, which means that they support iteration. You can do this sort of pattern over them. So using this special new symbol, add@iterator, you can invoke this method on any collection, and you'll see you get the exact same thing. We can sort of consume the data in this collection one item at a time. So all of this next stuff can get a little tedious after a while. I'm checking this weird tuple. And so we've added a special for-of loop. This is a new loop that looks similar to the for-in loop, but it behaves differently. Under the hood, it does exactly what the previous slide does. It requests an iterator, pulls out each value, and then evaluates the block. So as we can see, if we run this piece of code, we get 42, 39, and 17. Now, if generator functions return iterators, why aren't they called iterator functions? Well, there's more than meets the eye to generator functions than just iteration. In fact, a generator object is a combination of two other types of object, an iterator, which you just saw, and an observer. So those two interfaces together make up the generator interface. So the generator is an iterator, and an iterator is a data source. It's something that we pull values out of. And there's three messages, notifications you can get from an iterator. You can pull out a value. When you attempt to pull out a value, that iterator might throw, and so you could get an error. And finally, you can pull out a value and find out that it's the return value. In other words, the last value, and there will be no more values. But here's what's interesting. A generator is also an observer. So in addition to being able to pull values out, you can push values into a generator. And it supports the same three messages. You can push a value into an observer. You can send an error into the observer with the throw method. And you can also send a final value into the observer, indicating that you're not going to send any more values in ever again. And so notice that this is push. So once again, a generator is an iterator, which is a data source, but it's also an observer, which is a data sink, something that we push values into. Why would we want to do this? What's the value of being able to push a value back in? Well, iteration itself only allows data to flow one way from the producer to the consumer. But a generator allows feedback. So as we pull a value out, we can then turn around and push a value in at the same time. So what's this good for? Well, it allows us to build a pattern called asynchronous iteration. And asynchronous iteration is a really, really powerful way that we can combine promises and generator functions together to wait instead of block. So yield, although it looks like a statement like return, is actually an expression. And when you push a value into a generator that you get out of a generator function, the yield expression is actually replaced with that value. So once again, just as with iteration, we have a producer, which is the getStockPrice function we have here, and a consumer, which is this special spawn function, which I'll explain later. You pass a generator function to the spawn function, and the outcome is a promise of the eventual result. So what does this look like? So there's the spawn function, which is the consumer. Let's take a look at how it works. So if I was to run this code right now, it's a promise, and it eventually evaluates to the current stock price for Pfizer. So to understand how this process works, let's take a look at a diagram. So here's how asynchronous iteration works. Now, iteration means the consumer is in control. It's the consumer that decides when it pulls a value out of the producer normally. Except in this case, so first we request a generator. The producer requests a generator by calling the getStockPrice function. And the function hands a generator object to the consumer. The consumer calls next and pulls out a value, and now the producer executes some code. See at the bottom right there? It's gotten to this piece of code here where it goes yield getStockSymbol. Now getStockSymbol is going to evaluate to a promise. And so what we're really doing is the producer is going to hand a promise to the consumer. Now there's an agreement between the consumer and the producer. The consumer is going to fulfill this promise by calling the then method and passing in a callback, and it's going to wait until it gets a value back before calling next again on the producer. And this is why it's called asynchronous iteration. Now the next time around when the consumer calls next, I want you to look very carefully at the bottom right of that screen. We're actually taking the value that we realized from the promise, and we are sending it in. We are pushing it back into the producer at the same time as we're requesting another value. And so we're actually kind of sending PFE back into the producer. Now look at the at the bottom right-hand side of the screen. We'll see that the yield, which looks sort of like a return, is actually replaced with the value that was pushed in. So var symbol becomes PFE, and that's how we can sort of realize a promise and write code that looks synchronous. Now, at this point, the next line of the producer code is executed, and we yield getStockPrice. We pass in a symbol that we just got, which is now PFE, and that creates another promise, which the producer sends to the consumer. And now the consumer honors the agreement. It fulfills that promise before it calls next again, and the next time it calls next, it passes in the output from the previous promise back into the producer. And that value that's pushed at the producer replaces yield. So now price is $27.83. We jump to the next line, and we return price. And so the producer hands that value back to the consumer and also says, we're done. So let's take a look at real code. So here we can see that the spawn function accepts a generator, and it returns a promise. Now notice here, this promise actually accepts a function with two arguments, and that's the function to call when a value is intended to be returned from the promise, accept, and reject. If an error occurs, that's the function we have to call to push an error to whoever happens to be listening to this promise. So the very first thing we're going to do is we're going to execute this onResult function, which we're going to recursively execute later on. So the first thing we do is we call next on the generator, and notice here on the top screen that we've paused here at the very first line of that generator when we come across a yield. getStockSymbol evaluates to a symbol promise, which we yield, and notice now in the spawn function, we've replaced the symbol promises now being assigned to the value property. So we're not done, and we know the value is going to be a promise, so we go ahead and pass the then method to it and recursively pass in a pointer to onResult. We skip back up to the top, and this time what's passed into the function is the result of that symbol promise, which is Johnson & Johnson, or J&J, the symbol. We skip to the next line. This time we push J&J back in to the producer, and the yield expression at the top of the screen, yield symbol promise, is going to be replaced with what we pushed in, J&J. So we skip to the next line of the producer. We pause at the yield, and we evaluate the getStockPrice. It turns into a promise. We yield that. So now the consumer, spawn, is pulling the promise out of the producer. Because it's a promise, it calls then to try and fulfill it, and recursively passes in the onResult function. This time when the onResult function is invoked, it's invoked with the result of the previous promise, which is $4.20.25, the price of the stock at the moment. Then we turn around and push that value that we've realized from the promise back into the producer. It replaces the yield expression, and we've assigned price to the current price. Now we skip to the last part of this function. We return price. This time we notice that done is true, and that means we're ready to accept this as the eventual value of the promise that spawn is returned. And we can see below, when I execute this code, what's going to happen with that blinking cursor. Finally, we're going to get the result, 420.25. And that's how asynchronous iteration works. So it's really powerful to see how generators and promises can be combined. And this is all JavaScript 6. We haven't even gotten to talking about ES7 yet. So as a matter of fact, this spawn function is available with a special library that you can download called task.js. And so by downloading this spawn function, you can write code that waits instead of blocks using generator functions. And then all you have to do is pass that function to the spawn function, and out pops a promise. So you can go here and get task.js. It's at taskjs.org. Now, I promised that I was going to talk to you about what ES7 is doing for async functions. Now, the question we want to ask ourselves is, if this is such a common thing in JavaScript, if we want to wait so often instead of block, and we want the code to look roughly the same whether we're waiting or blocking, well, why should you have to download task.js and get a spawn function? In ES7, we're looking at providing language support so that everybody doesn't have to download a library, and this stuff is just built into the language. So in ES7, you can replace this code, which we saw from the previous slide, with this. We have a new async modifier for functions. And if you put the async modifier on functions, you can use this new await keyword, which functions like the yield keyword in the previous example. When you call await on a promise, it essentially pauses, it waits for that promise to be resolved before continuing the function. Now, that's really important because we're waiting and not blocking. Although this looks like blocking code, we're actually waiting, which means your web server is free to process other requests, and the UI will remain responsive. So starting with ES7, this will be the sync version of this function, and this will be the async version of this function. Not bad, right? So async functions are in the draft stage. And I'll just talk a little bit about that. I mentioned that last time. That means the committee expects that this will be part of the language. You can try async functions today by going to Facebook's excellent regenerator transpiler. So that was written by somebody on the committee. And you can go and grab that from Facebook/regenerator and use the branch that has async await in it. And you'll actually be able to transpile ES7 code into code that you can evaluate in the browser right now. So try out this feature. We're really interested in feedback. So the await keyword in async functions makes it easy to wait on a value. But what if you need to wait on a stream of values? What would I mean by that? Well, let's take a look. So let's say I want to write a function that gives me the next major price spike for a particular stock. And so I'll pass in the name of the stock as well as a threshold. And I want to kind of consume some WebSocket, some stream of stock prices. And as soon as the previous stock price and the next stock price, if the delta between them is larger than the threshold, I want to return that delta. Well, a stream is really just not too different than an iterable, if you think about it. All these push data sources, it's really that we're observing instead of iterating. Data is being pushed at us instead of us pulling data out. And so there's really nothing wrong with, you should be able to write this a for-on loop to be able to loop over push streams like WebSockets. So in this example, I'm using a for-on loop. Now this isn't in ES6, this is something being proposed for ES7. So in any async function, it would be ideal if we could use a for-on loop to loop over events. Now, there's only one problem with that, which is that there currently is no observable data structure for the web. The web has so many different push data sources, but there's no common interface. Notice that in ES6, we introduced a common interface called iterable, but currently there's no common interface for observables. So let's contrast what I mean when I talk about observables. So we remember the iteration and how that works with the consumer pulling values out of a producer. Well, the way observation works is it's different. Instead of a consumer requesting a generator from a producer and then pulling values out, in observation, a consumer hands an observer to a producer, and the producer pushes values at the consumer. Observation and iteration are not really that different. They're both ways for a producer to get values from a consumer, or excuse me, for a consumer to get values from a producer, one item at a time. The only difference is which party's in control. In iteration, the consumer's in control and is pulling values out, but notice in observation, the producer's in control. It decides when the next value is pushed. Think about things like events, for example. You hand a callback to an event, and it decides when you get the next value, not you. So here we can see the same information that can be sent from producer to consumer via iteration can be sent by observation. And finally, the observation can be the producer can send the consumer, hey, I'm done message. Now, the web, we have so many different ways of observing streams of data. We've got DOM events, WebSockets, server-sent events, node streams, service workers, jQuery events, XML HTTP requests, set interval, and the list goes on, actually. And all of these have different approaches for sort of, maybe you give it a callback, maybe it has a termination message, maybe it has a special message for errors, maybe not. What we'd like to do with ES7 is rectify this problem. In order to add language support like for for push streams and allow developers to work with all these push streams that they have to work with nowadays, we'd like to add a common interface that anybody can implement called observable. Now this observable is actually very simple. We just derive it from the iterable interface. Notice when we contrast the iterable interface of ES6 and the one that's being proposed for ES7, all we're doing is we're swapping the arguments in the return type. So an iterator accepts nothing and returns a generator, and an observable accepts a generator and pushes values into it, and it returns nothing. So it's got a nice symmetry there. So in order to get data out of an observable, you hand it an observer. So here I have, this is sort of like handing a callback to a mouse move event, except we're handing 3 callbacks. One to accept data, one to accept a return value, and then one to accept an error. So if we do this, the producer pushes these values out at us one after the other, over time, asynchronously. Now, we can take this pattern, just like iteration before is kind of ugly, this pattern of observation is a little ugly, and we can actually add special syntax for it. So one, we could add a special for each method that works a little bit like an array, but it returns a promise that resolves when the actual asynchronous observation process is completed. But within an async function, we can introduce this new for on loop. And going forward, what we hope to see is on the web, lots of people start adapting existing push APIs to observable, assuming this proposal succeeds, of course. So you should be able to go out there, and even if an observable API doesn't really support this new interface, you should be able to write conversion functions. Here's an example of me using a toObservable method to adapt a WebSocket to this new observable interface, and then use a for-on method to list all the people who are, say, signing up for Netflix over time. So one thing that's really interesting about observable, and it's very similar to iterables in this way, is that it's composable. You can solve complex concurrency problems by using underscore-like libraries, or we hope that people will develop underscore-like libraries, to help you compose together observables. Here's an example of a piece of code that you don't really need to fully understand right now, but it's just showing how we can declaratively compose together several event streams, mouse downs, mouse ups, and mouse moves, to create a mouse drag event. And then use for-on to consume the drags for a particular element, and then move it around the screen. So you can try this observable type, or at least something very similar to the one being proposed for ES7 today. And there's actually libraries out there to help you compose it together so that you can declaratively build complex concurrency programs and really string together all these different push sources to build web applications. And so RX, which I use personally, and Bacon is another thing that uses this observable type and allows you to use underscore-like a library to combine them together. Now, there's a question that hasn't really been answered, and it's kind of an elephant in the room. If there's an async function and it returns a promise, and a function star, a generator function, returns an iterator, well, what does an async function star return, right? Here, we can sort of see these features in a table here. We've got a function that's synchronous, it just returns a value. When it's asynchronous, it returns a promise. A function star that's synchronous returns an iterator, and so there's kind of a missing piece. So a generator function returns multiple values. And an async function differs from a normal function in that it pushes one value, right? When I say pushes, what I mean is you hand a promise a callback, and then it pushes the value to you in the argument position of that callback, rather than the return position of a function. So if a generator function is different than a normal function because it allows you to return multiple values, and an async function is different than a normal function in that it pushes its values rather than returns them, well, an async generator function would have to push multiple values. And what type pushes multiple values? An observable. So an async generator function is going to return an observable. So here's an example. Instead of my getPriceSpike function, which you saw earlier, which returns a promise which resolves when the next price spike occurs, I could just as easily build a stream of all the price spikes over a certain threshold. So here we see async function star. This is an async generator function which returns an observable. We're using for-on to consume all the prices in a WebSocket, and we're looking for deltas between prices. And whenever we get a delta between a price, we yield it. And that creates a stream that we can then observe. Little error on this slide here. Sorry, error on the previous slide, right at the bottom. We want to be using it. That looks like get price spike returns a promise. It actually returns an observable, so sorry about that error. So another issue that developers are facing, particularly in the Node.js community, but browsers may be facing it at some point too, is asynchronous I/O. Asynchronous I/O is more complicated than just simple observation because sometimes we need to support this concept of back pressure. Let's say you're observing a push data source and we're pushing data at you, and the consumer is trying to write that data out to, say, a sink, like, for example, a file writer. Now, the problem is if handling that data that's arriving, that's being pushed at us, is also an asynchronous process, we need to be able to slow down the observable that's pushing data at us until we've completed handling that data and pushing it out to another asynchronous data source. And this is sometimes called back pressure. Well, as a matter of fact, there is a pattern that you can use to solve back pressure in order to be able to let you write code that looks like it's blocking and is actually waiting. And that involves observable, and it's actually called asynchronous observation. So it's actually the direct opposite of asynchronous iteration. So let's take a look at what that looks like. So here's synchronous I/O with a function star. Let's imagine we were using a synchronous file reader. Sorry, a little typo on the slide there. That says async file reader. That should read sync file reader. So Node.js, for example, allows synchronous file readers. And down there at the bottom, it says async file writer. It should be sync file writer. So here I am. I can model a synchronous file I/O, as a generator function, right? I can loop over, and while the reader hasn't finished, I can read lines out of the stream, and I can yield them. And then I can read that stream of that iterator that I've created, and then write it out to another stream. Now, async I/O with async function star looks almost identical. So here we are in this example, we're waiting, and we're actually using async I/O to do the exact same example. I want to call your attention to something, which is the await yield statement there. What that's really saying is when we yield JSON parse line, that expression is actually going to turn into a promise that's being returned from our attempt to sort of write this out to the stream, and then the loop is going to pause. We're going to await that promise before continuing, and that's how we get back pressure. So I'll show you how that works. So async observation is a lot like async iteration. The consumer, because it's observation, the consumer hands an observer to the producer, and the producer pushes values into it, just like before. However, when a value is pushed to the consumer returns a promise. And this promise basically represents the promise that will be fulfilled only when we've successfully written that data out to the output stream. Now, in asynchronous observation, the contract is switched. In asynchronous iteration, the consumer promised not to request another value until it resolved the promise. In asynchronous observation, the producer promises not to push another value until it resolves the consumer's promise. So the producer waits until the data has been successfully written to the writer stream, and then only then does it push another value at the consumer. That consumer attempts to write that value to the stream, creates a promise, sends it back to the producer. The producer waits till that promise is fulfilled before finally sending the last value. So the relationship between asynchronous observation, asynchronous iteration, and iteration and observation, we can see it's clear in how you can use these patterns and their different permutations to solve the really types of problems that developers are facing today. So it's really important we understand how all of these patterns relate to each other. So let's take a look at how this works. I want you to take a look at the bottom of the screen. I'm going to replace that for on. I'm going to de-sugar it. In other words, I'm going to show you the type of code that it generates. And that's actually an await. So we're going to call for each. We're going to pass an async function in, which means that for each is going to evaluate to a promise, which is going to be resolved when the for loop's finished. But that yield expression, notice the yield expression above in the producer, is going to be replaced with the promise from that for each. And so we will await when the for each is, excuse me, not the for each, but the body of the for each, where we're actually writing out that promise. And so we wait for the writer to write the data, and we get the promise back, and then we await that before we continue looping over and pushing more data. So you can find more information on async function star by going to this repo right here. And it's important to know that this particular proposal is in the straw man phase, which is the earliest phase, and we're really looking for committee feedback on this. So as I said, straw man. That means we're just looking for open feedback. So here's some resources you can check out, and thanks very much.